Question number 9 involves squaring both sides of the equation to get rid of the radical, and that's fine for A, B, and C. That's fairly simple to do. As we square both sides, we're able to get rid of the radical term. Now we still have to watch out for extraneous solutions and all that, but that's perfectly fine. D is a little bit different, so I'm just going to put a little star next to D because this involves a binomial radical like above, but there's a plus in here. And that plus really messes things up because if we try to isolate the root, we end up with 5 is equal to root 3n minus root n. Those are not like radicals, so we cannot combine that together, which means that when we try to square this, we're going to generate an extra term, and we aren't able to get rid of the radical term when we do that. So the way we can do this then is we need to square this still, but squaring is going to generate an extra radical term. And if we square it like this, like I've shown here, this is actually, it will work, but it actually gets a little bit complicated, the algebra. So it's easier to solve a problem like this by isolating one root at a time. So I'm going to not work with that, and I'm going to work with this original equation, and it's already isolating one root. So I'm going to square that root, and that will get rid of the root on this side. But when I square this side, I cannot square across that plus, so I have to multiply. And I'm going to end up with a radical term as my middle term. So when I multiply this out, I get 25, 5 plus root n, and then another 5 plus root n is going to give me 10 root n's. And this is a term that's then the problem. Squaring the root n gives me root n, so it gives me just n, and on this side I have 3n. So now I've gotten rid of the original square roots, but I'm left with this extra root n. Okay, now this is a problem, but we can still isolate that root n, and then we can eliminate the root radical. We can get rid of the radical by squaring both sides. So this is what we're going to do. So we first isolated one radical, squared it, we generated an extra radical term, and now we solve for that extra radical term. So I'm going to end up with n minus n from both sides, so plus 2n minus 25 from both sides, like that. Okay, now I can divide both sides by 10 and square to get rid of the square root, but we're going to end up with an n term on the left-hand side with a coefficient, so we're just going to square both sides like this. Okay, so now we're going to get rid of that second square root, and we end up with 100. 10 squared is 100. Root n squared is n. And now I've gotten rid of the radical terms. I've generated on the right-hand side, though, a quadratic equation. So we're going to end up with negative 25 times 2 is negative 50, and we're going to do that twice. So we're going to end up with minus 100n. 25 plus 25, so 25 times 25 is 625. So there's a quadratic equation that I have to solve for. Okay, I actually forgot to state my restrictions here, so I just bear with me. I'm going to state my restriction that n must be greater than or equal to 0. Okay, so solving this quadratic equation, we're going to make this equal to 0. 4n squared minus 200n plus 625. There's no common factors to simplify. It's a quadratic equation. I could try to factor this, but I don't think it's factorable. So I'm going to solve for n using the quadratic formula. So I get 200 plus minus 200, negative 200 squared is 40,000 minus 4 times a times c. That's all over 2 times a. So 2 times 4 is 8. So simplifying the radical term, I get 40,000 minus 4 times 4 times 625 gives me 30,000. Okay, so that looks like 4 times 625 is going to give me 12, 25,000. Yeah, I think that's going to be 30,000. Let me just work that out again. Four times 625 gives me 2,500. Okay, so I have to fix that. So this term here is 2,500. Okay, and oh, sorry, that's going to be 10,000. Okay, so my math is getting bad here. So this is going to work out to be 10,000. Okay, so there we go. And then that's going to be all over 8. So simplifying this, I get 200 plus minus the square root of 30,000 all over 8. Again, this can simplify to 200 plus minus. I'm going to factor out the 10,000. So that becomes 100 root 3. And that's all over 8. And that's my solution. Now I need to check for extraneous solutions, and I'll do this in a different video.